All right, AP Calc, Part 2 of Lesson 2 from Section 1.1. We're going to be talking about linear stuff and whatever else we can through the next 15 minutes. So the first thing I want to talk about is basically finding equations of lines that satisfy certain conditions. I'm only going to do one to kind of refresh you guys on this. X intercepts 4 and the y intercept is negative 3. So look at number 63. We want the equation of a line that goes through the point 4, 0, because that's what it means to be an x-intercept. It means it crosses the x-axis at 4, 0. The y-intercept is at 0, negative 3, okay? And we know that the generic equation, the default setting for a line is y equals mx plus b. Well, the good news about this one is they've given us the b. The b represents the y-intercept. The question is, what's the slope? So the slope of any line can be registered with this formula. And it doesn't really matter which one you assign to be x1, y1, or x2, y2. Just keep it consistent. So here's x1. Here's x2, here's y1, here's y2. So it'd be negative 3 minus 0 over 0 minus 4. So it's negative 3 over negative 4, which is positive 3/4. So that's where m's going. And you're done. Number 67 is one that's a little more complicated. So I'm going to start... well, let's read the directions first. It says, find an equation for the perpendicular bisector of the segment AB. All right. A little bit different than just writing an equation of a line given 2 points. So the first thing I want to do, just to give myself some perspective on this, is plot the points, okay, and then talk about what it means to be a bisector. So 3, negative 1, there's A. B is negative 2, 6. And it's up here. And the line segment connecting those two looks like that. Now, a perpendicular bisector a lot of times is accomplished by taking a compass, measuring from A to B, and then making a notch up here. So you take your compass, you go up here, you take your other compass, you go up here. It actually creates a line segment that intersects this at exactly 90 degrees. That's why they call it a perpendicular bisector, because it basically cuts the segment in half, all right? It like 2 equal parts and creates a 90-degree angle right there. So what we're really looking for is the equation of the line that kind of looks like that. So the first thing we need to be able to do is figure out, okay, we need to know what point that is where the line crosses, and then we need to know what the slope is of this perpendicular line. So the first thing is we can find the middle point of that segment by using the midpoint formula. So if you've forgotten, the midpoint formula basically states that I just got to find the average between the x's and the average between the y's. If I do that, I've got the midpoint. So 3 plus negative 2 divided by 2, and negative 1. Did I put a B? I meant to put a 6 down. Whoops. All right, so they intersect at 1/2, comma, 5/2. That looks about right. In fact, that looks exactly right. I have a really nice drawing right there. Okay, 1/2, comma, 5/2. So that's going to be important when we're actually going to be, plugging things into y equals mx plus b. I think we found the x and the y that we're going to plug into this equation to find other information. Now, one piece of information that's going to be super helpful is to know how perpendicular lines interact with one another. And it's all about the slope. All right? If we figure out that the slope of AB, okay, so let's do that first. So y2, 6, minus y1, -1, divide that by x2, -2, minus x1, 3. You get a slope of 7 over -5. Right there. Now, perpendicular lines are basically, okay, you probably remember this back in the day from a previous math class, and it's kind of been forgotten. You flip the fraction, and you make it negative. They're called negative reciprocals of one another. So if the slope of a regular segment is 7 over -5, the slope of the line perpendicular to it is going to be -5 over 7 made negative, so positive 5 over 7. And by the way, if you ever have to deal with parallel lines have the same slope. Okay. So we got the information we need to write the equation of the line. We know that the slope is 5/7, and we know that our x-coordinate is 1/2 and 5/2. Given that information, we're going to be able to solve for b in this equation. So let's get some more room over here and get to it. So you got y equals mx plus b. My x is going to be 1/2. My m is going to be 5/7. My y value is 5/2. And really, the b is the last unknown in this situation. So you got 5/2 multiplying fractions straight across, 5 over 14 plus b. All right, I have to subtract this from both sides. Which really this just requires common denominators. So I'm going to multiply the top and bottom of 5/2 by 7. So you get 35 over 14 minus 5 over 14. Which is 30 over 14. And that reduces to 15 over 7. All right, so this was really a wonky equation. I guess in real life things don't work out with nice, neat whole numbers, so go figure. Our equation is going to be y equals 5/7 x plus 15 over 7. All right, I'm going to try to fit in one more. It's not about lines. It's more or less just applying sort of an equation of something that's more of an application. Go to number 77 in the textbook. Which I believe is right here. All right, so we got an interesting little eye equation. All right, don't poke your eye out. 77 basically gives us an equation. Again, you can read it in your own textbook. We're talking about object magnification. where m is the ratio of the image size to the object size. And we got a whole bunch of stuff happening here. Basically, they're saying this equation gives us perspective on the distance p from the lens, the focal length f, and then m is basically talking about the linear magnification. They're saying if f is 6 centimeters, how far should the object be placed from the lens so that its image appears at least 3 times as large? So what they're doing is they're giving us 2 pieces of information. The first piece of information is they're saying let f be 6. F is 6 centimeters. So you know what? I'm going to try to do this over here. So m is equal to 6 over 6 minus p. I can't solve an equation if there's 2 variables, right? I got 2 variables. Here's the thing, though. This last statement. Yeah. How far should the object be placed from the lens, okay, so that its image appears at least 3 times as large? They're saying that m should be 3, I believe. The ratio of the image size to the object size should be 3 to 1. That's how we should analyze that. So go back to m. Plug in 3. 3 times as large. The image size to object size is 3 to 1. So you know what? I'll just write it as 3 to 1. At which point we just have to cross multiply. So 3 times 6 is 18. 3 times negative p is negative 3p. And then that all equals 6. You're left with a basic math 1 equation to solve this thing. So subtract 18 from both sides and divide by negative 3. So your final answer is, how far should the object be placed from the lens? Should be about 4 centimeters. All right, I'm going to restart the video and do the last couple examples.